Hi, I'm Tate.
And I'm Davis.
And this is our brief video presentation for Part 4 of Experiment 5, the Comparator. Alright, this is our setup here, our breadboard. And you can see our LED there, V out right here, V in right here.
Pot in our LED.
Yes, and there's the thing that makes it all happen, the op amp, 747. This is our oscilloscope. We paused in the middle of a reading. The blue is our input frequency, and the yellow is our output frequency. As you can see, what the comparator does is when the input voltage is high, when there's a peak, the output of the amp is a constant positive output, and when the input is a trough, a low input, low voltage, the peak is a constant negative output.
And
for V out.
As you can tell, the V out is not perfectly square because the slew rate's not as high as you would want it to be ideally, and that's because as it's changing from positive to negative, well, I guess positive 1 to negative 1, it's already coming back on the way back up. So it's not instantaneous.
Right, it doesn't switch between positive and negative output instantaneously, as it does ideally, or as it would ideally.
Yeah, and you might see that later on when we actually run it, which we'll do once we finish talking. It doesn't, a couple times it doesn't actually, V out doesn't actually come all the way down to a peak of negative.
Or to the constant negative 15.
Yeah, to the constant negative 15.
Not exactly a peak, I guess. And there's the circuit running. Turn down that a little bit. So yeah, as you can see, as our input, which is a song, is actually playing, the comparator is switching back and forth between positive and negative output according to the input voltage.
And as we just said, as you can see a couple times, the peak or valley is not all the way at its maximum value.
You get, let's see if we can capture one of those.
You can see it right.
Yeah, you can see it right here.
And on the left as well.
The input voltage varied a little too fast for the comparator to actually switch to negative, maximum negative output. Okay. Also, we can observe the output visually with the LED light here, and when the amp is generating a positive output, we have the LED lights up, and when the amp generates a negative output, we have no light. Right now it looks like it's constantly on because it's switching back and forth so fast that the LED just appears to stay lit. And if we adjust the pot a little bit, we can get a flicker from the LED. Can you put your hand behind there?
Yeah.
And the flicker is the LED switching on and off. If we can just, there we go. So now you can actually see the output voltage switching back and forth. It's still at a pretty high rate though. What else? Practical application?
Yeah. Well, I'll say my practical application second.
Oh, yes. One practical application for this we thought of is basically this setup on a larger scale with a bigger light array, and your input could be a microphone, and you could get a visual output for a response in a beat of a song, so you could have visual response to music, light switching on and off with each beat.
So it's rhythmically being lit up. I think they now have those on some T-shirts I've seen at music festivals. People actually wear. It looks like a, what is it called? Equalizer, the EQs.
Yeah, the EQs.
That they wear on their shirts, and the shirts can actually respond to the beats as they're coming in.
Lame.
Similar to how the op amp works.
And I think we've covered everything then. And thus concludes our video presentation for Experiment 5.